What we're going to be working on today is solving polynomials of higher degree, solving radical equations, and absolute value equations. So higher degree polynomials right now, our method to solve that is going to be to factor. And remember, in order to factor, we have to make this equal to 0. So if we add 3 to both sides, we're going to get x squared minus x to the fourth minus 4x squared plus 3 equals 0. Now, this is in quadratic form. I know it's not a quadratic equation because quadratic equations, the highest exponent is 2, but it's quadratic form because we have a quadratic function would be x squared plus x plus, a number plus c equals 0. Well, if we do x squared squared, we get x to the fourth. And if we multiply this invisible 1 exponent by 2, we get 2. And then we have our constant. So we can treat this like a quadratic and factor it. So we say what two numbers multiply to 3, but add up to -4? Well, that's -3 and -1. So we can rewrite this as x squared minus 1 times x squared minus 3. And the reason it's x squared is because our middle term was an x squared. When we would factor something like this, our parentheses would be x, plus a number, x minus a number, and then, we would set them each equal to 0. And we're going to do the same thing here. We're going to set each of these equal to 0. Now, this first factor, x squared minus 1, you could factor that even further, or you can just set it equal to 0 and solve. Either way is going to be okay. I like to factor it completely. So x squared minus 1 is another difference of squares, so x plus 1 times x minus 1. And then we have x squared minus 3. Okay, the zeros now, this equals 0. Our zeros, we're going to go to each factor and set it equal to 0. Well, that's going to be x equals -1 because -1 plus 1 is 0. For this one, x equals +1. But for this, because it's x squared, we have to set this up as x squared minus 3 equals 0. And then when we add 3 to both sides, we get x squared equals +3. And then when we square root both sides, we have x equals plus or minus the square root of 3. So we have 4 solutions. We have x equals -1, x equals +1, and x equals plus or minus square root of 3. All right, now with radicals, last year you talked about and learned how to solve equations with one radical, and that meant we had to get the radical by itself, the single radical by itself, and that gave us the square root of 3x minus 2 equals x minus 2. And then we had to square both sides. So we squared both sides. On the left side, that would cancel the square root, and we're left with 3x minus 2. And on the right, you would have to multiply out x minus 2 squared. So this is why we talked about those factoring shortcuts. Yes, you could multiply that out, but knowing that expansion shortcut will give us x squared minus 4x plus 4. Like I said, but you could still multiply that out. You could do x minus 2 times x minus 2. It'll just take you a little bit more time. Okay, then we will solve this. It's a quadratic because we have x squared, so we're going to get everything on the side with the x squared. Minus 3x from both sides and minus 2. Plus 2. And that will leave us with 0 equals 0 equals x squared minus 7x plus 6. And then we can solve that by factoring x minus 6 times x minus 1. And then our two solutions will be x equals 6 and x equals 1. Now, because we squared both sides, we changed the degree of this function as a whole. Okay, this was a first degree function because our highest exponent was 1, but when we squared it, now we made it a second degree function. So we could have added some extra solutions because remember, second degree functions have two potential solutions where linear or first degree functions have one. So we need to now check our solutions. So in the calculator, we're going to check both solutions, and we need to check them in the original right here. All right, so square root, second square is 3 times x, so 3 times 6 minus 2, and then outside the square root minus x again, so minus 6, and we want this to equal negative 2. Okay, it does for that one. Okay, so we're going to go up and now change these 6's to positive 1. And again, we want to make sure it equals negative 2. This equals 0. So this equation has an extraneous solution. X equals 1 does not work, but 6 does. So that would be our only answer. When we have two radicals, what we're going to have to do is we're going to have to square twice. So first we need to get one radical by itself and square both sides. It doesn't matter which one you get by itself. I'm going to choose to do, I don't like dealing with negatives, so I'm going to add this one to both sides. So then we get the square root of 3x plus 4 equals 1 plus the square root of x plus 5. All right, now we're going to square both sides. Now remember, because of this plus sign right here, we can't just distribute the square to each term. We have to, again, either write it out or use the shortcut. But on the left side, they cancel. So it's going to be 1 plus 2 times the square root of x plus 5 plus x plus 5. So I just used the shortcut. You can FOIL it out if you would like. And that's why we were saying that if you knew the shortcut, it makes other things a lot easier. That became much easier to multiply out. All right, so now what we have to do is get the radical by itself. So we will then get everything to the left side, but first, if we can combine like terms, we will. We have 1 plus 2 times, so we can't do anything with the 2 times square root of x plus 5 plus x, but we can combine the 1 and the 5. So that's going to be 6 plus 2 times the square root of x plus 5 plus x. All right, so we'll minus 6 from both sides, and we will also minus x from both sides. That is going to give us 2x minus 2 equals 2 times the square root of x plus 5. Well, we still don't have the square root by itself, so we divide both sides by 2. So on the left side, this will become x minus 1 equals the square root of x plus 5. So then we will square this again on both sides. The left is going to be x squared minus 2x plus 1, you're going using the shortcut, equals x plus 5 because the square root and the second power cancel. Okay, so get everything on one side, minus x and minus 5 from both sides. So we get x squared minus 3x minus 4 equals 0. So we factor that and say two numbers that multiply to negative 4 but add to negative 3. Well, x minus 4 and x plus 1. So our two potential solutions will be positive 4 and negative 1. So x equals 4 and x equals negative 1. And just like the other example, we need to check to see if both of these work in our calculators. And we're going to check it in on the original. So our solutions were 4 and negative 1. Well, we can kind of tell that maybe negative 1 isn't going to work because we have... All right, so let's try these. Square root of 3 times 4 plus 4, and then minus the square root of 4 plus 5, and we hope this equals 1. It does. So x equals 4 works. So then we're going to do the same thing, but plug in negative 1. 3 times negative 1 plus 4, then minus square root of negative 1 plus 5. We get negative 1. Okay, well, we can't have that. That doesn't equal 1. So negative 1 is not a solution. X equals 4 is our only solution. All right, now absolute value equations. First, you need to manipulate the equation to get the absolute value bars by itself. Luckily for us, both of these already have the absolute value bars by themselves. But if you need to manipulate, add stuff, subtract stuff from both sides, divide stuff on both sides, we want the absolute value bars by themselves. Once you have that, you split this up into two separate equations. 3x plus 7 equals positive 4. And then 3x plus 7 equals negative 4. And what this does is it changes just the sign of the right side, where we go positive 4 and negative 4. The inside stuff stays exactly the same. The absolute values bars go away. We leave that left side alone. We change the right side. And then we solve them separately. Subtract 7 from both sides. We get 3x equals negative 3, and x equals negative 1. Then in the other one, again, subtract 7 from both sides. We get 3x equals negative 11. Divide both sides by 3. X equals negative 11 over 3. So then you want to, again, check both of these in our equation, the original. So to do absolute value, we do alpha window. The first one is abs. 3 times negative 1 plus 7, and we hope we get 4. Okay. And then we'll do this again. 3 times negative 11 over 3, close parentheses, plus 7, and we also get 4. So both of these are viable solutions. When we have absolute value equations, we could have no solutions, one solution, or two solutions. Right, now, letter B is a bit tricky because we have a variable on that other side and we have an x squared. So it's going to be x squared minus 6 equals x, and x squared minus 6 equals negative x. And we're going to solve both of these separately, and they're both quadratic, so we could have two solutions for each of these. So we could check, we would have to potentially check maybe 4 solutions here. So minus x from both sides, we get x squared minus x minus 6 equals 0. And then we factor that to x minus 3 times x plus 2 equals 0. So our possible solutions are 3 and negative 2. Those are our possible solutions. Now I'm going to solve the other one first before checking these, because maybe there's going to be some overlap. Maybe this other one also has x equals 3 as a solution, but it's possible that it doesn't. Here we're going to add x to both sides, so x squared plus x minus 6 equals 0. And then we're going to have to factor that. We get x plus 3 times x minus 2 equals 0. And then our possible solutions are going to be negative 3 and positive 2. Now, we're going to check these in the calculator. We got to check again all 4 of them. Back in the original. So I'm going to check the positive ones first, just because it's easier to go back and change them. So we had positive 3 squared minus 6, and we want it to equal x. So we plugged in 3 for x, so when we hit enter, we hope it equals 3. Okay, it does. So x equals 3 is a solution. Now we're going to go back up here and change it to x equals positive 2. And then we hit enter, we get positive 2 as well. So we know that these are at least 2 solutions. Now, when we type in the other ones, okay, you don't really have to do that for 2 reasons. One, because negative 2 squared is going to give you the same thing as positive 2 squared. The difference, though, is we can't have the absolute value equal a negative number. So when we plug in negative 2 for x on the right side, it's going to give us no solution. And when we plug in negative 3 for x on the right side, again, your absolute value can't equal a negative number. So we know x equals negative 3 won't work. If that didn't make sense, you can just go back and plug them in. You can plug in negative 2 and negative 3. And you will see that you will not get the original x value you plugged in. So we're bringing back solving quadratics, but also throwing absolute value in as well. So thanks for watching. Make sure to like this video and subscribe.